All right, hello math hustlers and the parents of math hustlers. This is Mr. Heath, and I'm going to go over the topic that we'll be dealing with tomorrow, or should I just say Tuesday. It is going to be identifying proportional and non-proportional relationships in tables. Now, how does this apply in the real world? So just give you an understanding of why this mathematics is sort of important to your child to learn, or for you to learn as a student. Let's say you're selling some shoes, and the shoes cost $200 for a pair. What we'll do is we'll take this relationship between these two things and we'll set that up as 2 over 1. What does that mean? For every one pair of shoes sold, you're going to get $200. How's that important? Well, let's say that you're running a store and someone walks in and says, you know what, I'd actually like 10 pairs of those. How that would play out mathematically would be is that that ratio would then be multiplied by the value that's presented or entered into the computer or the register, and it would come out with 2,000 over 1. Obviously, you find that quotient, and then it would be $2,000. And so we do this a lot with machines. We go to the store, and I mean, just a ton of different situations. So the ideas and the thinking behind ratios are very important to real world situations, everyday life, in the world of business, and so many other things. All right, so with that said, let's go over this challenge here. So this challenge that says identifying proportional and non-proportional relationships in tables. You're going to need what we call some foundational math skills, and these foundational math skills that you'll need for this will be division. Foundational math skill is the ability to add, subtract, multiply, and divide whole numbers. So let's say 4 plus 4. Well, let's use division, so we're talking about division. The ability to divide whole numbers, so let's say 4 divided by 2, or the more traditional format. You're going to be seeing this way more than you're going to be seeing this. Like, I know you saw it a lot in elementary math, not very much in middle school and high school math and onward, okay? So division involving whole numbers, okay? And then another form of division that you'll see is division involving decimal numbers. So it might be something like a 6-pack or something for 99, and then maybe there'll be 6 of them in that one. In the more traditional, so the use of decimal numbers there. And the one that's really intimidating, foundational math-wise, is a division of fraction numbers. So something like that, which is more typically seen as. So I'm not going to go over these skills. I'm going to go over them in another video. But if you don't have these skills, you will not be successful at identifying proportional and non-proportional relationships, and particularly in this real-world situation. So if you're not good at dividing whole numbers, decimal numbers, fraction numbers, you can take a look at a video that I'm making for this one that kind of accompanies this one. Also, if you want to build up your skills, I would suggest going to the internet, YouTube, Khan Academy, getting that and working on the skills. In addition, you can talk to me, and like I do in class, I'll help you as much as I can. And then outside of school, I can always help you when it comes to after school at lunchtime, building up these what we call foundational math skills. All right, so now let's get into our background music and let's get into the topic. So the topic was identifying proportional and non-proportional relationships in tables. So we have a table here, and this is the original challenge. We have a table right here, all right? Has hours worked, has pay. Before we go on here, let's talk about, I know there's a table there, but let's talk about the influencer. And the influencee. All right, for our wind up. So as you look at this challenge here, and it says hours worked to pay, I think most people, particularly the adults, would say that the hours worked is definitely going to influence the amount of pay that they get. All right. So I just want to make sure you understood that, students. Not important right now because we have a table we're filling in, but definitely important when we get to finding the correct answer for this. So let's go ahead and take a sample paper that I put together just to sort of guide this process. So as we look at this table, we notice it says hours worked 1, pay 8. So we're seeing a pattern here. 8, 16, 24, 32, 36. Wait a second. It was, okay, 8 plus 8 is 16. 16 plus 8 is 24. 24 plus 8 is 32. But 32 plus 8 is not. It's 40. Okay, anyway, so I see a pattern here as I'm filling this in. Same thing here. 1, 2, 3, 4. Wait, 4.5, 5, 6, 6.5, 6 5/10. So if I'm trying to figure out if this table is proportional or not, there were two ways I can see this. So we talked about the idea that composed unit. So where we have two things together and we see them as one. We can finally see now, like the hours worked in the pay, it just says one composed unit. So as we take this one composed unit, one way to definitely find out if these values or these ratios inside this table are proportional is just by finding the quotient. And as we find the quotient of a ratio, if it is consistent the same from ratio to ratio, then we have a proportional relationship. So let's go over here. Now you can see where the influencer and the influencer becomes very important. So notice in my denominator of my ratio, I have the digit 1. Why? Because that's the hours worked. I have the 8 up here. Why? Because that's what I got paid. Notice how the hours that I work influence the pay. If I work 2 hours, I get paid $16, but my rate is still $8 per 1 hour. So let's go through her. It says, let's look at the quotient. That quotient is 8. 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 But it's half. It's not the same. But yes, it is. The quotient is 8 because it's 4.5. All right. So we go over the quotient is 8. The quotient is 8. The quotient is 8. So what we notice here is that the quotient is consistently 8. That's a proportional relationship. Now another way you can look at this, and I think it'll also help you understand this idea better, is the idea of multiplicative property. So another way to find out if it's proportional or not is just you can see if they're using the same multiple value or amount, if you like that, if they're applying that to the original starting value. So let's go over here. The original was 8 over 1, 8 over 1. Okay. So I'm moving from applying 1 to the numerator and denominator to applying 2. 2, 2, 16, 2, 3, 3, 4, 4, 4.5, 4.5, 5, 5, 6, 6, 6 5/10, 6 5/10. And here's the interesting thing here if you're really noticing. I apply that same digit here. So notice 1, 1, and if I go up to A, 8, 2, 2, find that quotient, going up to B, 8. 3, 3, find that quotient, go up to C, 8. I think you kind of get the idea here, okay? So we sort of see how they're inverse of each other in the situation. So consistently have the same quotient or consistently applying the same value to the original starting ratio. 1, 1, 2, 2, 3, 3, 4, 4, 4.5, 4.5, 5, 5, 6, 6, 6 5/10, 6 5/10. So if we look at this chart, we definitely could say that the rate of pay is proportional. How do we know this? Because we see the rate of change is consistently the same. It's 8. And we can see for the hours, they're consistently applying the same rate to the hours here. 3, 3, 4, 4. They're not changing it up. All right, we're going to go further in class about the thinking behind this, but this gives you a pretty good beginning and understanding of this, all right? So start this video. Even if you're in class, you don't understand, I think you should go back and take this video. I will have you do that. All right, so enough about proportional or identifying proportional, unproportional things. And I hope the video helps. All right, this is Mr. Eve.